Hello everyone, this one is a calculator Olivetti Logos 58, produced around 1973. I will show the calculator, its interesting printer, and also the internal parts, with an insight on the state of the electronics in 1973 and its advancements compared to few years before, and also the very particular design of the keyboard without subkeys. There isn't the display, so the result was printed only on the paper. It was considered more professional because the numbers on display disappear, but the paper remains. As usual in the manual, there are very nice handmade drawings. Here it talks about settings and regulations of the various parts of the calculator. This is the textbook for a technician course taught by Olivetti's technical support department. Of course, big part of the manual is dedicated to the printer. At the end of every section there is a little exam. There is a section that explains in detail how it works the keyboard. It's very interesting. On top it seems a normal keyboard. But if you look in the side, you see some metal rods. And in the back there is some electronics. There aren't the subkeys as usual. Then there are 7 magnetic switches, these. Near to them there are also these magnets on a little pendulum. They move when a button on the keyboard is pressed. When the magnet on the pendulum is near to the center of the magnetic switch, this is closed, so interrupting the contact between these 2 points. For example, when the magnet is far from the center, the switch is open. So when you press a button, these metal rods we saw before moves the magnets, setting a combination of switch opened and closed, different for every number. So if you look at the manual, you can see the pattern of how logic circuits generate numbers. For example, to generate the number 1, only the switch A must be closed and all the others are open. This is the calculator without cover. It can be easily disassembled in well-defined blocks. Compared to old mechanical calculators, the maintenance is simplified and it's simple to disassemble and reassemble. I will leave the link of the big mechanical calculator Logos 27.2 from 1967 in the comments, so you can understand how it was difficult to repair big mechanical calculators. So these are all the parts. You can see it's made by 6 blocks. The keyboard. The console with on-off switch, rounding and commas. The printer. There is the belt that transmits the movement from the motor. A solenoid, the red one. The power system. Here there is the motor moving all the mechanism. Then there is the electronic board. This is the main processor, a Texas Instrument TMC 1828, assisted by these other 2 components. It's a quite simple board with a few components. If you have seen the video in this channel on the 1967 Olympia Ray calculator, which used about 20 electronic boards, you can imagine how far we have come in just a few years. I leave the link of the video in the comments. The printer uses a ribbon-only 5 mm wide. This is the ribbon mechanism, very nice. The Logos 58 use a printer designed directly by Olivetti. There is a cylindrical print head with 2 rows of 12 characters, numbers and symbols. It seems the printing ball of the IBM typewriters, but the same system was already in use at the beginning of the century. The mechanisms are moved by the motor here on the right via this belt. Then there is a series of gears and cams that transmit the movement to the printing ball. It prints from right to left. There are up to 20 columns of digits. It printed 25 characters per second. The printer is more silent than the usual and more advanced compared to ones of the previous period. It has a non-conventional triangular design. It was one of the first Olivetti calculators using electronics. The Logos 58 was part of a family of 5 models. Logos 55, the basic model. Logos 58 with the percentage button and 2 accumulators. Logos 59 with an additional totalizer. Logos 68 with square roots, square numbers, and with a capacity of 23 digits compared to 16 for other models. The Logos 70 is a programmable calculator. It could memorize the sequence till 256 operations. You didn't program by typing lines of text, but it's the calculator that memorizes automatically series of calculations. If you turn off the machine, the program disappeared, so the Logos 70 used a magnetic card reader to memorize the sequence needed. And now how it works. This is the wheel for decimal rounding of the numbers, and this is the decimal showed till 7. This is the power switch. When the calculators power up, this LED is red, showing an error. Pressing this Rex Clear key resets the machine, and you can start operating. There is also this button, meaning keyboard clear, to erase the incorrect entry and to clear the error when 2 keys are pressed at the same time. Here there are the numbers and the keys for addition and subtraction. When you make many addition and subtractions, the calculator accumulates in the memory the total. When you finish, if you press the T, total, the calculator cleans the memory, while with the S, subtotal, the memory is not cleaned. This is the percentage. The enter button is used in multiplications and divisions, for example like this. The button R recalls the result of the last multiplication or division. The constant button sets a number you use in division and multiplications, for example to multiply a list of numbers for the same number. The ACCP key is used to automatically accumulate the results of multiplications. The ACCQ key does the same thing, but for division. I think it's an office calculator, but with very advanced functions. To use it at its full capabilities, you have to study a lot. But I think if you work in accounting, it's worth it. At those times there was already the electronics to help. Look at the calculator of the mechanical era and see the difference. Have a nice day.